historic here, and that's in analysis data, DS infectious historic, you'll notice that it says do not update automatically. This is all sort of manually filled in here. And it's going to be filling it in with the values from that table function in this case. So it's going to take those all and put them into the data set. Okay, now, what this is saying is before each run associated with the data set, now you have to be careful here because this says before each experiment run. So here we are doing it once before the whole experiment has taken place. We're going to reset the current objective, reset the information on the best feasible objective. So in other words, we're going to zero out the information on from anything we've seen before on what's best. This logic deals with the fact that we may, for example, run this. So I'm going to run this right now. Remind you of what it. So you remember these calibrations. We have some data historic that we want to match here, this yellow data, and we can run it here, and it's trying to find different matches to it, and this is measuring the best so far, and it's identifying with the red the best that's been found so far. This is identifying the goodness of fit of that best so far. We could then, if we were to stop this.
What's best number 4?
Sorry? Yeah. Yeah. Yeah.
Is that like the fourth one?
I think that was sort of the fourth attempt. It actually found, or the fourth iteration, the fourth point in space, in that parameter space, it actually found the best, because we've gone 16 iterations and it found at number 4 it actually got the best value. It's trying to find better values than that, but the best it's encountered thus far is number 4. It's as if you were climbing a mountain and you've gotten to some peak locally, and you're trying. It's kind of cloudy, so you can't tell for sure there's a higher peak, but you're kind of exploring around that. It may require you to go downhill a little bit. You're following some ridge. Now that ridge may lead to a higher peak later, and in fact, if we were to continue on this, I just restart it, but here it's found number 5. Okay, now that's interesting. Here it's number 4 for a while, and then okay, now this is interesting because this is not going up uniformly. It's actually sometimes going down there, which I'd have to try to understand why it actually decreases from time to time. That's probably it. Yeah, right. So these are the 2 cores on my computer, and so one may finish before the other, and so that's probably it. Locally, it seems to be going up in general. It's just that one may take longer than the other, so occasionally it sort of goes back or what have you. So still number 4 was the best one, and it's searching around for a new peak. You can imagine it going along a ridge and trying to find something higher. Generally speaking, it's going to follow a gradient up higher if it finds one. Here it actually got a little bit lower here, so now that's replaced that number 4 with number 56. Now it's been replaced with number 68, and you'll notice that those things corresponded. This was number 4. It came way down here. Number 56, it came down here. Number whatever it was, 68, and in number 80, it had a little bit of a decrease, I guess, between this and that or what have you. So it's coming down. So this is reporting the best thus far, and that's the objective function. This is for the current one. What's the objective function? And it'll occasionally get replaced by that when this is below that. Okay. You notice some of the early objective functions were up around 2,000. So we've done pretty well in finding some good values. And by and large, you'll notice trend is somewhat downwards here. But but that's not to say that we don't occasionally go down into a swamp. Forgive me for sort of mixing up the min and the max, but occasionally we'll get sort of way off from the peak we're seeking, or way off from, if we're trying to minimize, sort of get as low as possible, we'll occasionally end up on a ridge or something. But by and large, it's getting somewhat better over time. Although, this was actually better, and then it started to get worse, and et cetera. So the point here is that if we were to stop this, and I were to restart this, what should happen? If I want to restart, so I stop the whole experiment, and I say, okay, I want to start this now. It should clear out everything. And so if I start this now, it should sort of reset what was the best, and indeed now it's back up to 600. And so, folks, that's why we saw this logic here for before the experiment run, reset the current objective, reset the best feasible objective, the best one it's found, and sort of the current value of it. Okay. And then what we're going to do is that it's going to be recording now for different replications the best value, and then combining those estimates for a given iteration, which consists of several realizations or replications. Okay, so you'll recall that ABMs exhibit significant stochastic